Today we're doing lesson 33 and 34, so we're combining the rounding and estimating with the dividing with zeros and the quotient. So both of these are kind of review for what we have already done so far this year, because we've already done the long division with zeros and our quotient. So starting today, we're going to start with lesson 33, which is all about rounding and estimating. So if you look at this first example, it says when we do not need an exact amount to describe a situation, we can always round it to a specific place. So it says that we see 67 falls between 60 and 70, but it's closer to 70. So that means that we would round 67 up to 70. Okay? You can pick, if you're a visual person, sometimes picturing it on a number line like this will help. Also, for the next one, it says round 523 to the nearest 100. If you don't have a number line or if you're not visual, you can go back to your basic rules of rounding, which means you underline the place that you're rounding, and then you look directly to the right. If the neighbor is less than 5, that means that the place that you're rounding stays the same. So the 5 would remain a 5. Everything after the 5 turns into a what? A 0. Very good. Okay, rounding numbers can help us estimate the answers to problems when we don't need an exact answer. So if the question, for example, says about how many blah, 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 then you could pick a number to round your whatever numbers you're given. You can pick a number to round them to make it easier to solve. It doesn't mean solve for the exact answer and then round your answer. You're still working hard, and you don't have to work that hard if it's an estimation type problem. If you round your numbers more times than not, it's going to be a lot easier to do mentally in your head than it is if you don't round them. So let's look at an example problem. It says in a presidential election, each state is assigned a certain number of electoral votes. Based on the 2000 census, the state of Florida was assigned 27 electoral votes, and the state of Texas was assigned 34. About how many electoral votes can a candidate win altogether in those states? So when it says about how many, boom, right then, you should be able to look and see, okay, well, 27 is close to what? 30. Oops. And then 34 is close to 30. So in my head, I can add those two together, and it's going to be about 60. Good. Mm-hmm. The average depth of the East China Sea is 620 feet. The average depth of the Yellow Sea is 121 feet. To the nearest 100 feet, about how many feet deeper is the average depth of the East China Sea? So I would take this one and this one, and what operation do I want to use?
100.
How many feet deeper? What does that mean I'm doing? I'm subtracting. So I'm doing 620 minus 121, but because it says about how many feet deeper, I can make this a lot easier on myself, and I can use what I call compatible numbers. So I may not round 620 all the way down to 600 and 121 all the way down to 100, because what is 121 close to that I can subtract easily from 620? 120. So I would change that to this problem here, and can you do that in your head?
Yeah.
For sure. What would my answer be? 500. So about 500 feet deeper. Okay, here's another one. A community theater group is giving 4 performances of a play. The theater can seat 424 guests. All of the tickets for each performance have been sold. So estimate the total number of guests who plan to see the performances by first rounding the number of guests for each performance to the nearest 100. Okay, so 400, whoops. This gets rounded to 400. Then what do I do?
You multiply. 1696.
I need to multiply? Why?
Because there's 4 performances.
Uh-huh. Why am I multiplying and not dividing?
Because that would be making it lower number.
Uh-huh, total number. Now, sometimes total means add, right? But when I have something like this and then I see another word that says each, I'm trying to make my number bigger by the word total, But because I have each in there, I know I'm either going to be multiplying or dividing. Well, if I divide, what happens to my answer? It gets smaller, not bigger. I'm looking for a total, so I should be growing my number. So about 400 times 4, that's easy peasy, because what is 4 times 4? 16. Add your 2 zeros, so my answer is 1600.
1696 is the exact answer.
Okay, this just kind of breaks down. Okay, this kind of breaks down that same problem just in a different way using compatible numbers. So it's saying that 424, we could say is pretty close to 425. Why? Because 25 is easy to multiply by 4. What's 25 times 4?
100.
Yeah, you think quarters, it's 100. So if you rounded 425, then you can multiply that easily by 4 too in your head to even get a more accurate estimate too. Okay, last one, I think, before we move on. Leela's car traveled 129 miles and used 4 gallons of gas. About how many miles did the car travel on each gallon? What do I do, Natalie?
You take 129 miles and you should probably round it to 130 miles. And then you would divide by 4.
Okay, now can I do this in my head?
Well, oh yes, you could. Because you take the 4 and it can go into.
Is there something else I could round 129 to that I can do even easier in my head? 120. Very good.
Oh, I thought it was going to be 100.
That's using compatible numbers. But 100 could work, but 120 is even closer. And why is 120 compatible with 4, John?
Because 12 times 3.
Because 12 divided by 4 we know is 3 and then a 0. So about 30 miles. Okay, see how compatible numbers make it easy for you to do quickly in your head? You have to be able to identify them though. If you can't, then you could round down all the way to 100. You just won't have as accurate of an estimate. Okay. All right. Dividing with quotients or a 0 in the quotient. Our steps are right there. Divide, multiply, subtract, sometimes compare, bring down. Okay. If I were solving this problem, somebody tell me the very first thing that I would need to do. Okay, Luke.
See how many times 6 can go into 3?
Which is how many?
0.
0. Then what?
You put the 0 down below the 3. And
You don't have to. That's true. But you can.
you get 3.
Uh-huh.
Put down the 6.
Yep.
And then 6 goes into 36 6 times. 6 times 6 is 36. You get 0. You bring down the 5. 6 can't go into 5. So you put a 0 up top. And 6 times 0 is 0. So you have an under 5.
Very good. So that's what we're going to be doing. Uh-oh. Nope. Don't do that. Hang on.
Easy. That's easy. That was good.
No, something had happened. Somehow I did like a screenshot. So anyway, okay, moving on. Here's our first problem. A train traveled 630 kilometers in 6 hours. To find the average speed of the train, divide 630 kilometers by 6 hours. So I would take 630, divide by 6. Who wants to walk me through this? Okay, Ty, go.
So 6 goes into 6 one time, and you subtract 6 from 6, you get 0. You bring down a 3. 6 can't go into 3 anytime, so you put a 0 up there. You put a 0 below the 3. You subtract, you get 3. You bring the 0 down, and 6 can go into 35 times. Then you subtract 30 from 30 and you get 0.
So my answer is 105 what?
mph, miles per hour.
So MP, because it's kilometers. But yes, normally we use miles, so we think MPH because it's miles per hour. Oh, kilometers per hour. There we go. KPH.
Miles per
Yeah, miles per kilometer does not make sense. Do not label that. Okay. 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 An object on the moon, this is our last one, then we start our practice. An object on the moon has a different weight than the same object on Earth. To estimate the weight of an object on the moon, divide its weight on Earth by 6. So if Jason weighs 115 pounds on Earth, we're going to estimate the number of pounds that he would weigh on the moon. So what would I round 115
6
to?
divided by 115. Oh, you rounded to
120.
120? I'm dividing it by 6.
You're gonna divide it by 120.
I could change the 6 to a 5. Do I want to do that, or do I want to try and change the weight, estimate the weight?
No, 120 pounds. 100.
6 into 15.
Round it to 100.
118? Would that work?
Yeah. No.
Or
120.
we could just go
120.
120. Okay. If I rounded 115 to 120, I could do 120 divided by 6, and it's about
20.
20. 20 what?
20 pounds.
20 pounds. Very good.
I weigh 10 pounds.
He weighed about 20 pounds.
About 20. Right. Today your assignment is going to be lesson 34. Starts on page 232 to 234. So lesson 34. Be sure you're in the correct lesson, not 33. Be sure you are on page 232, and it's just 1 through 30.